All right, I will start officially. So welcome everybody. I've put the link to the slides for today's presentation in the chat. And I'm here to talk about remote robots. I'm here to talk both about, very briefly, about how they work or how the way that we've made them work works. And also I want to share some stories from the last year of educators who have used the remote robots technology to do a lot of different things. It's actually a really cool blossoming of creative projects. So first I should start and kind of define remote robots. So a remote robot is a robot that can be programmed over the internet. So it solves the specific problem where maybe I have a robot here in Pittsburgh and I want you as a student to be able to program that robot and to be able to program that robot in a friendly blocks-based way. And so this idea was prompted by the pandemic. In March of 2020, we saw schools kind of shutting down as a company and as a person who's very interested in furthering kind of hands-on robotics education in schools. I knew that this would be kind of a problem. And so I decided to kind of start developing this technology. And what really helped was that there was a lot of work already done previously to make remote robots work. And that work specifically is the development of the NetsBlox programming environment. So I see Akos is here. So NetsBlox, as some of you know, is essentially a descendant of Snap that adds networking capabilities to the Snap environment. And so our robots at BirdBrain Technologies work in the Snap environment. And so it was possible for us to fairly quickly take our libraries and our implementations for Snap, import them into NetsBlox, and then leverage the NetsBlox networking capability to create a remote robots kind of setup. So something that would work where I could send a link to a blocks-based programming environment to anyone in the world, and they could program my robot, and it would actually work. So by April, we actually had some robots that were, April of 2020, we actually had some robots that were programmable over the internet. All right, so before I show you those robots and the robots that other people have developed, I want to talk a little bit about kind of definitions. So I'm talking about remote robots today, and that's the situation where you have the robot and you want your students to be able to program them over the internet. So, you know, this is the kind of situation that honestly many schools were in at the beginning of the pandemic, because sometimes the teachers may have taken the robots home, but there was not a situation where like all of the students had robots. Now, what we did see evolving kind of in the summer and fall of last year was a different model called one-to-one robotics. And that's the situation where everybody's got a robot, but everybody's also at home. So your students have a robot to program. You as a teacher may have that as well, but you still have all of the challenges of remote teaching. And so, you know, we needed to, as providers of robotics equipment, we needed to provide some materials to help teachers teach and coach effectively. And we've done that as well. And then the last situation that we saw more recently, which is particularly interesting and exciting, we saw this in the spring, is the hybrid situation. So this is where you have some students who are remote and some students who are in the classroom, and everybody's programming robots, and you want to make sure that the remote students are getting as much out of that experience as possible, and hopefully are learning roughly the same programming concepts as the ones in the classroom. And we saw, I'm going to talk later about a Finch implementation where we saw a teacher do that really effectively. So I realize now, about like 5 minutes in, that I didn't actually introduce myself. So I'm Tom Lauwers. I'm the founder of a small robotics company in Pittsburgh, Pennsylvania, called BirdBrain Technologies. And we provide two products, the Finch robot and the Hummingbird robotics kit. And so the remote robots implementation that we developed back in March of 2020 works with both of our products. And it actually works with older versions of our products as well. So the Finch is a little programmable robot that you program that moves around. The Hummingbird is a kit of parts that kids turn into robots using arts and crafts and other materials. So because these robots are kind of different, the kind of ideal remote robots setups for each of these are also fairly different. And I'll talk about that a little bit in the coming slides. All right, so how does this work? So I already mentioned that remote robots leverage NetsBlox. And in our particular implementation, we have created essentially two NetsBlox projects. One is a server file, or I refer to it as the server file. The other is the client file. Now, the client file is public and shared. And so that way I can using link sharing, I can send the link to the client file to anyone in the world. And in that client file are blocks for controlling our robots, like Finch move forward. And when somebody clicks on that block, that client file sends a message through the NetsBlox cloud to the server file that I am running here or with me. And that server file is directly controlling the robot. So once my server file receives a message from the client file, it then sends a command over Bluetooth to move my Finch robot or move my Hummingbird robot. You can have up to 3 robots connected to one computer. So in practice, we've seen setups where you have 1 robot. We've seen setups with 3, and then multiples of 3 is typically what we've seen. What's cool about this is the sensor data from the robot also can be sent back over the internet to the client file. And so you actually have access not just to controlling the outputs on the robot, but to controlling the sensor or to reading the sensors and then acting based on that sensor information. Now, the full loop here is about 2 seconds. So from when I get the sensor information is about a second out of date when it gets to your client file. And then it takes roughly another second to send an output command back to the robot. So that means that you can do some sensor-based programming, but you can't necessarily do all of it. And the example I like to use is with the Finch robot, we have a distance sensor to avoid obstacles. And you can do that actually in real time as long as you keep the speeds relatively slow. So you can build an actual obstacle avoider that works over the internet. We also have line tracking sensors. And the line sensors, when you're tracking a line, you need that feedback cycle to be on the order of hundreds of milliseconds, and it just does not work. It's not possible to do with a remote robots setup. So there are some limitations because of that lag. Dave says like robots on Mars. Yeah, more like robots on the moon, I think is actually the more appropriate, because that's about like 2 seconds round, or 2 and then 2 more seconds, so 4 seconds round trip. But yeah, so there is lag. So what did we do with this? So the first thing we did, as I mentioned, is I set up 5 remote robots using the Hummingbird kit in my house in April of 2020. Those robots are actually still running. They're still on the internet. You could program them right now. There's a couple of them sitting near me. They're at birdbraintechnologies.com/remote-robots. The link is at the end of the slideshow as well. And that was sort of my first proof of concept. And those are visible over Nest cameras, which are great in that they provide a public live stream, and less great in that their public live stream is about a 15-second lag. The second thing we did is we started doing all sorts of remote robots sessions and classes. We actually did one at Snap Conference last year for students. And we also did these at computer science conferences. So those sessions mostly use the Finch robots because the Finches tend to be great as synchronous kind of remote robots. So when you do this in a video call, you don't have that kind of Nest camera lag. You really do see things happen very quickly. And so it is a great introduction to people to programming robots. And, you know, especially in the past year of kind of social distancing, it really allowed people to do something unique in a virtual conference, right? You're programming a real robot over the internet. So that's mostly how we use the technology. And then in, I think, April of 2020, I put up a tutorial for how to make your own hummingbird remote robot. And then the Finch robot actually only came out in December of 2020. So we put up a tutorial for how to make your own Finch remote robot in December. And so I just want to share some stories of different people and organizations who use the remote robots in interesting ways over the past year. So once those tutorials went up. So the first person who kind of pioneered the remote robots idea, and she presented this at the SNAP conference with me last year, is Erin Whitaker. And she had a hummingbird robotics project going in her classroom when the pandemic hit and shut everything down. And she was looking for a way to keep it going and, you know, hoping that we'd kind of come out with a simulator or something like that. And I said, well, I'm working on this other idea. And she was very game to try it and actually tried some of our, like, she basically helped me make my tutorials better. I sent her the sort of Google Doc tutorial and then she improved it. So she had her students design the robots and then she built them at her house and put them on YouTube live streams and had her students programming those robots. So this was a small implementation. It was 9 students, 3 robots, and they were programming. Eric Fogel did a similar project, but at a much larger scale in the fall of 2020. He built 12 robots. He set up 4 computers with 4 cameras. He used the school's Microsoft Teams, Microsoft Teams software to allow kids to basically just view those robots over Teams. So they were logging into a video call and then had them program those. And he had 600 students program these 12 robots. Everybody at his middle school programmed the robots. It was amazing that he got that scale. And I think, you know, whenever we get out of this pandemic, like that is one of the promises of remote robots, is just, it allows you to scale with a fairly small budget. You don't need to buy, you know, a kit for every 2 students. You could have a kit, 12 kits in this case, for 600 students. So it does scale pretty well. Obviously, there are limitations also, but I think it's a good way to get some students excited. In winter of last year, I saw a project in Vienna, Austria, where they put up a public remote robot. And it was actually better than mine because they figured out, hi, Andrea. Yeah, so DigiKids put up this robot and made it work and ran workshops themselves, but also made it publicly accessible. So I actually got to play with it, which was really fun, like programming a robot from 4,000 miles away. And what I like about this project as well is that as somebody who didn't grow up in Austria, it taught me a little bit about Austrian culture. And that, because the robot itself was about like the story of Franz and Sissi, the emperor and empress of Austria in the 19th century. So I learned a little bit about that. And that, I think, shows another kind of promise of this technology, which is to use it in potentially as a media for people to engage with one another and to connect one another across different cultures. And then once the Finches came out, Terry Kelly in Virginia built a Finch arena and had her students programming these. Again, this was sort of initially a remote model and then a hybrid model. And she initially programmed them with NetsBlox, but she was teaching AP Computer Science A. So we also figured out a way for the Finches to be programmable remotely in Java and Python. So she used this, and again, she built the arena out of some very low cost materials, right? Just PVC pipe, put a webcam on top, and just that way you can view the robots. And then the last thing I want to share is a new company that came, that was founded by a couple of the former employees at BirdBrain Technologies called CodeJoy. And they have been using remote robots in these kind of interactive TV shows. So every session, every workshop is an hour long, and it has a plot and a story arc. And as part of that story arc, the students are invited to program the robots, to kind of to help the robots along, because usually something breaks in the robot and you kind of have to help the robot by programming the robot. So it's a really cool implementation. This one no longer uses NetsBlox. They kind of rolled their own thing, but it's still a great, showcase of what remote robots can do. So that's it. Like I said, you can program my robots right now at this link, and I'm happy to answer any questions for the next 5 minutes or 4 minutes.
Hi, Tom. This is Akos. Great stuff. Quick question. So the NetsBlox messaging has about 100 millisecond delay. So where does the rest of the delay come from?
I think part of it is Bluetooth. I also throttle the blocks. So I only allow like one. So in like the output blocks, I think I put in like just a 0.3 second delay or 0.2 second delay in some of those, because when I didn't do that, it was overloading. Like you would get a message queue piling up. Mm-hmm. So there's some in Bluetooth, there's some in the intentional throttling, and then I guess there's some in NetsBlox. But I didn't actually know it was about 100 milliseconds on the NetsBlox, and that's quite fast.
Yeah, I mean, it depends on a lot of things. So that's the number we get when we use our Wi-Fi robots. So that's actually multiple round trips, and it's very fast.
Wow. Okay.
I just want to mention that we are in the process of moving the location. So 5 days ago, we have removed them, but we will put them up, I think, in autumn again, if you're interested in the.
Yeah, that's great. So you'll keep them running for. I wasn't sure if you were planning to like.
No, definitely. But we are probably thinking about a new scene, because it doesn't always have to be the same. It makes fun to think about new things. So we were so excited about it. Actually, it took us a while to get it running, but it was interesting. And this issue about the webcam, so maybe we also on our side can improve it, because that's the other side of the delay is when you have the webcam involved.
Yeah, although yours was much faster than my Nest cameras. Like it was much more responsive.
Hey, Tom.
Hi, Dave.
Could you trace the flow from what the programmer is doing through the various pieces, including the Bluetooth? I'm especially interested in the Bluetooth to the robot part.
So the Bluetooth to the robot part is a version of that is the next talk in a couple minutes. But the way that we control our robots, so we have either a web app that does it or an offline application. With the offline application, our blocks are communicating with that offline application. I think we're still using like the HTML blocks in Snap. We used to. With the web apps, we use JavaScript blocks. But basically, we're using like the connection. We're doing the like Bluetooth communication in an offline app outside of Snap or NetsBlox, and then communicating with Snap or NetsBlox using either HTML or JavaScript blocks, depending on which implementation we're using. And so, like I said, like when somebody clicks a block in their remote project, it sends that message over the internet to our local project. It sends the parameters of like what speed or how far you want it to travel and that kind of thing. And then the local project interprets that. What a nice thing about that is you can control what they are allowed to do by configuring your local project. So this is especially important in the Hummingbird, but even with the finches, I intentionally like made it so that the finch the remote finches that people programmed, if they put 100% speed in, I just divided it by like 3 or 4 because it's a small arena and like I didn't want the robots moving that fast. So you can control what they're doing or what they can't do to some extent.